Hello, everyone, and welcome to Mr. Kranz's geometry class. So this will be lesson 1.1, and as we go through the year, these video lessons will continue. So if you go to your note guide, we're going to start off with vocabulary. We're not going to do all the vocabulary at once, but we're going to go through ones that are relevant to what we're explaining today. All right, so we start our vocabulary with something called a point. So a point are these right here, these little dots. Now, a point is a location with no size or shape, meaning it's only indicating where something is. So if I put a point here and I put a larger point here, since it has no size, it doesn't mean that this one is larger than this one. That's not the way it works. It's just referring to a location, which really, if you think about it, is in the center of that point. Now, the way we name our points is with letters. So we would refer to this one here as point A, this one would be point B, this would be point C. So we need to get out of the habit, which you're going to wind up trying to do, is call this a dot. All right, and even I'll do it sometimes, and you should correct me when I do. But this is point A, point B, and point C. Next, we move on to, by the way, we should be filling in our note guides as we're going through this. A line. So a line is made up of points with no thickness or width. So if you look at this line, we have point X right here and point Y. Now a line goes on forever, meaning these arrows indicate that it keeps going this way with no end. So since it goes on forever, we can't measure a line. So a line has no measurement and no size. It also doesn't have a thickness, which is what it says, meaning that if I draw a line with just a thicker pencil, it doesn't mean that this line is any thicker technically than the other line. Now, the way we name lines is by the points that are on them. So this line right here, this will be line XY or line YX. So it's a couple of different ways. Now, right here, this is the notation for a line. So notation is just a symbol of a line with the two letters underneath. Now, this is line XY. It could also be line YX. Now, technically, you can have another letter that is off the line, such as like an L here. This can also technically be line L. Now, what if there was a third point on this line, like right here? Well, now this could technically be line XYZ, line ZYX. It could also be line YZ. It could be line XZ. Kind of get the drift. The only thing it can't be, it cannot be line X, Y, Z. And the reason is, notice that when I've been using all of these, notice it goes in order, X, Z, Y. Or it could be Y, Z, X. If I were to go X, Y, Z, what's going to happen is I'm going to go X to Y and then back to Z, which is out of order. So it can't happen that way. It has to be named that way. Looking below, we have something called a line segment. So a line segment is a portion of a line. Now, because it's only a portion, basically it's ended by 2 points, in this case, R and S. So when we have a line segment that has a definite end, it ends at R, it ends at S, it then can have a measurement. So a line segment is a measurable part of a line consisting of 2 endpoints. Now, a segment, because it has 2 endpoints, can only use 2 points, and it has to have 2 points. And this is the notation. It's basically a line without the arrowheads and just the letters. Now, this can be also line SR, RS or SR. Going down, we then have a ray. So now a ray is a line that extends infinitely in one direction. So think of it like the rays from the sun. So when you have your sun, right? It shoots off rays of light. Notice it starts from the sun and it goes infinitely in this direction. Now imagine if it didn't hit a planet, it would keep going forever. So that's how you kind of think of a ray. A ray is a combination of like a segment and a line at the same time. So in this case, over here, this is ray EF. It's notated with that same symbol, like looks like a ray with the letters. Now this one is a little different because it cannot go both ways. All right, this cannot be ray FE. Rays are always named from their starting point. All right, so this cannot be FE. All right, that does not work. It's only EF. Next thing we have is something called a plane. So a plane is a flat surface made up of points and extends infinitely in all directions. Think of it like a piece of paper. Imagine you're looking at this flat piece of paper, it's two-dimensional. And if that paper kept getting bigger and bigger and bigger in all directions, it would be a plane. Now, planes can be named by the points that are on them. So we can call this plane KLJ, plane KPL, plane LJP. It doesn't matter what order you put them in. Also, if there is another letter on here that is not a point, like say there was a little C here that doesn't have a point next to it, this can also be plane C. Planes don't technically have their own notation, so it'll just say the word plane. So we might actually see this as plane KLP, or it might just be plane C. All right, next vocabulary term we have is something called collinear. So points that lie on the same line are collinear. Now notice over here it says non-collinear points. Points that do not lie on the same line. That's the opposite of collinear. So co meaning the same and linear meaning line. So when we look at this line here, remember this could be line LMN, line NML, line MN, line NM, line MN, line ML, all those different ones. All those points lay on the same line. So we could say that points L, M, and N are collinear. When we go down, we look at coplanar. Just like collinear, points that are on the same line, coplanar means points that are on the same plane. And basically that's what it says, points that lie on the same plane. Non-coplanar points that do not lie on the same plane. So we could say that Q, R, P, and, well, I guess that would have been a B, but Q, R, and P are coplanar. I'm guessing that this drawing here is probably a B at some point, but that would also be coplanar, or that could just be a B without a point, and it could be called plane B. All right, next thing we have is something called congruent segments. So let's talk about the term congruent. Congruent means that things are the same length, same size, and the same shape. So they're exactly the same. Basically, think of it like a twin. But when you think of a twin, like an identical twin, they might be exactly the same, but they're not the same person. They're two different people, but everything about them might be the same. That's why identical. Even though people aren't technically identical, think of it like two cars that roll off the assembly line. If they're two Mercedes, they're all black, same option, same everything, they'll be identical. Those would be congruent cars. So the technical definition would be if two segments have the same length, they are congruent. So when we look at segment AB over here and segment CD, since they're both segments and they're both 7 inches, we can say that they are congruent. Now, notice that this just has AB and this has CD. And then next to it, this has segment AB and segment CD. Now, the segment symbol is a little line above the letters. This means equal, which we're familiar with. This right here, that means congruent. So the symbol for congruent is this little squiggly line and an equal sign. The reason why things are different here and why over here it says segment CD is congruent to segment AB or AB is to CD and this one here says AB is equal to CD. When we don't have the little symbol on top, notice how it's missing here? This is only talking about the length. So the length of AB is equal to the length of CD, right? The length of AB is 7, the length of CD is 7, so they're equal. When we have the symbol on top, such as segment AB and segment CD, that means we're talking about the shape and the size. So this is a segment AB and segment CD. So segments, when we talk about the shape, they're not just equal to each other, they have to be congruent, meaning this is the same shape, the little squiggly line means the shape, and this means the same size. So they meet both those criteria. For example, let's say I had a square, it's a bad square, let's call this a rectangle, and it has an area of 8. And let's say I have a square that also has an area of 8. Technically, they're equal in area, but since one is a rectangle and one is a square, they're not the same shape, so we can't say they're congruent. So that's kind of where that property comes from. So moving on to actually our 1.1 notes, some more explanation of our vocabulary. So this is a point. This is point A, if you've noticed. This is what it's named. A point is a location. It has no size or shape. It always uses a capital letter to name a point. That's why it's called point A. Going down, we have a line. A line is made up of points, meaning you have all these different points and it's connected with a line. Okay, you can't have a line that doesn't technically have points. Although a line can be named without having points on it. It just has points, they just haven't been pointed out to you or labeled. Okay, it always has points. So any 2 points form a line, meaning if I take any 2 points anywhere, I can connect it with a straight line. That's just a property, right? Any 2 points can be connected by a straight line. It doesn't hold true for any 3 points, because what if I do this? If I have 3 points, I can't connect them with a straight line. Any 2 points can be connected with a straight line. A line has no thickness or width. Name a line or any 2 points on the line, or a lowercase script letter. Meaning, remember I told you can have a letter that's not on the line? So this would be line N. This could be also line XY, or it could be line YX. Point Z has nothing to do with it. That is a point that is not on the line itself. So when it's not on the line itself, that is a non-collinear point. So we could say that X and Y are collinear, but X, Y, and Z are not collinear because they're not all on the same line. A plane, that's that flat sheet of paper. So when you think about a plane, so a plane is a flat surface made up of points. Any 3 points make up a plane. Because remember, if you have 2 points, it's just a line. A plane extends infinitely in all directions. Name a plane by any 3 non-collinear points on the plane, or an uppercase script letter. So in this case, we could say that K, J, and L are coplanar. It could also be plane KJL or just plane P. All right, non-coplanar points, coplanar points are points that coplanar points are points that lay, that should say lay and not line, lay on the same plane. Non-coplanar points that do not lie on the same. lines and planes? Well, intersecting just means meeting. So when two things meet, they intersect. So two lines always intersect at a point. See how these two lines, line R and line S, they intersect at line P? And then we could say that two planes intersect at a line. Notice you have a vertical plane and you have a horizontal plane. They meet at line K. All right, just like two walls. Think about when two walls meet at a corner. That corner is technically like a line. All right, so now in our exercises, we're going to use the diagram to the right to name the following. So let's name 4 collinear points. So those are points that are on the same line. When I look at it, I notice that points H, N, K, and I are all on the same line. So look at it. We have H, K, N, and I. Notice they're all on this line right here. Those ones are all collinear. Going to our next one, a line that contains point M. So if you look at this line over here, it contains point M. So we can name this line P. It could be line NO, MNO, ONM, NO, OM. Just cannot be MON. Has to go in order. So all of those are correct answers. Or the simplest one is line P. A line that contains points H and K. Well, H and K, well, that's on line HK, or we can just call this line R. All right, so this is just line R to make it simple. Another name for line Q. Well, line Q could be line JK, JL, KJ, LK, LJ. Lots of different options. You can use the 3 letters. Does not just have to be 2. All right, this could be line. There's many more answers than what's listed here. J, K, L. All right, the intersection of lines P and R. Well, if we look at P and we look at R, here's P, here's line R. Notice they meet right here at point N. So that'll be point N. Use the diagram to the right to name the following. A line containing point F. So if we look at point F, we see that point F is right over here, and it is on this line, so that'd be line J, or you can use those letters. Another name for line K, well, if we look at line K, we see it has CE, EB, BE, BC, CB. All those are different options. A plane containing point A, so we see that that is on plane M, plane M. An example of 3 non-collinear points. Well, those are points that would not be on the same line. So if you notice that A is not on the same line as D and E, so you can say that DEA, all different ones. ABD are not on the same line. The intersection of plane M and line K, well, if you see it meets at point E, going right through the center. By the way, the dashed part of the line, so this part right here, that just means it went through it and it's behind the plane, just to let you know it's still there. Use the diagram to the right to name the following. So 3 coplanar points, so points that are on the same plane. If you notice that V, W, and X are on the floor of that pyramid, which should lay on that plane. V, Y, and X are also 3. A plane containing point X, well, that would be plane R. The intersection of plane R and plane ZVY. So ZVY, let's look at it here. ZVY is this plane that's kind of straight up. And notice where it meets. It meets right here at line VY. So, I'm sorry, segment VY, because those have 2 endpoints that I colored over. See how it has 2 endpoints, V and Y, so segment VY. How many planes appear in the figure? Well, if you notice that there's quite a few, right? the reason it's 5 is because you notice the pyramid has 4 sides and then the floor, or plane R. How many planes contain W? So let's look at W. We find W right over here. Notice that W is on this plane right here, W is on this plane right here, and then W is also on the plane on the floor. Right? So we have 3 planes that contain plane W. Let's use this diagram again. See, we notice we have 2 planes, we have several lines, the intersection of lines L, and M. So here is line L, here is line M. Notice it meets at E. So that would be E. Another name for plane Q, that's a weird looking Q, I know. It could be plane IFG, any 3 letters that are on this plane over here, any 3 letters. Are points D and E collinear or coplanar? So let's find D and E. So D is right here. Notice that E is right here. They are not on the same planes, but they are on the same line, so they are collinear. And how many times do planes P and Q intersect? Well, when I look at them, I notice that these 2 planes, at least when I see them, they don't meet, right? They're just running next to each other. So technically, in our diagram, they intersect 0 times. Now, it's a little bit of a trick question, because as long as these 2 planes are parallel, meaning they run right next to each other, they don't intersect. But let's say, for instance, that this plane here, plane M, let me erase some of this stuff. Let's say plane Q, this plane right here, let's say it's slightly tilted, just slightly, the smallest amount. If these planes are going on forever, and notice that this keeps going up and up and up, won't it eventually meet our other plane, plane P? The answer is yes. So this is a little bit of a trick question. In our diagram, they don't meet. But in theory, unless we know they're parallel, we would say they do meet. All right, so that wraps up lesson 1.1. I hope you found this helpful. Please fill out your note guides and use this to help you with your homework. If you need anything, you may reach me through my email, Canvas, or Google Classroom. All right, take care, everyone.